Okay. Now, first start with the safety minute, right? As we discuss anything, we start with the safety minute. And here the safety minute, this is first 9 critical risks, which I am explaining you. 9 critical risks mainly in the process plant or any kind of manufacturing plant, and it is. This is a kind of critical risk, you can say. Any of the any of you any of you participants who have faced some challenges or some massive accident in the process plant, or you have seen in the process plant, because you most of you are working on the safety also, process and safety, and any of you can share. I mean, if you have something you want to share with that with your all the team members, you can share with me. Nothing.
Reliance industry. Domnall.
Yeah, yeah, yeah.
I worked in the sulfur recovery unit.
Oh,
Till
sulfur
the
recovery
shutdown,
unit. Right. Great.
yes, yes, yes. Till the shutdown, we need to hand over the column, stopper
Okay.
column,
Okay.
the contractor.
Mm-hmm.
During that time, there are having some sludges isolation we need to do, and we need to decontaminate it. After that, only we need to hand over to the contractor for do the job in the confined space.
Okay. Okay.
But during that time, the scaffolding they have erected, check the bottom nozzle.
Okay.
That time, permit was issued without checking inside the what the status of the scaffolding, whether it is completed or not.
Okay.
Engineer was issued that permit, and contractor started scaffolding. One plank was not there, working platform was not there.
Oh,
Con-
that's great. That's
yes,
not good. Yeah.
contractor slipped and he got first aid injury.
Mm-hmm. Oh,
But
okay.
confined space standby person has removed him, shifted to
Okay.
hospital. From
And
this
here,
learning,
okay, then what was the consequences on that?
consequences actually the worker has got injury. In this, the
Okay.
learning is need to check type platform, the scaffolding procedure we need to follow. Issue the
Okay.
permit, issuer has to check whether all the are getting ready to execute the job.
Yes, yes, yes. And that is my first part, work at elevation. And here the role of a scaffolding is a very important. And for that, there is a safe action plan. SAF is prepared, safe action plan. While working at the elevation, that is work, that is a prepared safe action plan. And you see, while if you are in the plant or any of the construction contractor or any of the engineering site engineer or site manager or resident construction manager or any of the team member or contractor or vendor who is working on site or who is visiting at site, certainly he has to attend a safety meeting which is conducted at the site. Safety meeting that ensures that explains how you are going to use the PPEs, personal protection equipments and all, personal protection equipments, and how you need to where you have to assemble in case of fire or in case of emergency and everything. I mean, that is that you are very right on working at elevation. Okay, now next is lifting and rigging. While lifting any heavy equipment and all, there's a proper document, proper rigging plan, and everything that should be prepared, and that should be approved also. Then mobile equipment like crane and hydra and all. While doing this, it is certainly that very important that all kind of checks, all kind of documentations, all kind of validation of equipment, that everything that should be there. Then comes energy isolation, log off, tag off. It is very important. While someone is working on a motor, someone is working on a drive, or someone is certainly he has to ensure that it is properly isolated. And I'm sharing with you consequences of this. Just a minute. Just a minute. This is a real. Okay. Now you can see, you can understand how critical, how important is isolation, right? Okay. Now next one is confined space. While you are working in a confined space where your plant or construction site or working area, it is in confined area, then you need to follow a certain rules which has been defined, certain safety action plans, everything. I mean HSC document which has been properly developed for that confined area. It is not a generic document which has been prepared, which has been you are following at construction sites and all. The confined space, it follows several rules, regulation, several techniques, how the crane movement and how working at elevation, everything I mean defined. It is altogether different for the confined space. Okay. Next one is electrical work. Certainly, all the electrical work whenever you are doing, certainly you need to follow the proper procedure, quality, and safety. Three things very important here. Everything you have to follow, electrical work and all. And now next one is excavation. While doing the excavation, everything that you need to assure that there is no like ST or LT wire in that while doing the excavation, because that might be while doing the excavation that ST wire that will hit with the your excavation excavator, and that may cause a severe massive accident. This accident I have seen with my eyes. The person who is doing the operating the excavator, he was not aware that while doing the excavator there is a high tension wire within the ground, and that excavator that touched the high tension wire inside below the ground. It is an old wire, and plant was using that, and now there was a massive accident. That operator, he could not come out with the excavator. Then hazardous material. Whenever there is a hazardous material, handling or transportation of anything, that needs to be taken care very properly, and material safety data sheet, everything that should be there. Then motor vehicle operations. Then motor vehicle operations, it is all depend. I mean, depends type of vehicle and all, and it if it is a liquid container or highly inflammable liquids and all, there are separate procedures and everything that is defined. Normally, because I tell you, because I used to give this kind of safety training also. Sometime I used to go to site and I used to explain, yeah, it is like that. That's why I am giving you subsequent examples. Anyway, now let's move to our next part of the discussion, basic engineering, right? Now, okay, how much you are acquainted with the basic engineering? Have you done complete basic engineering, or any of you worked as a lead engineer or co-lead engineer in a basic engineering team? Certainly, yes. Most of you are working on some project. You are doing an assignment, whether it is a basic engineering assignment or detail engineering assignment. So then the predecessor of the detail engineering design is a basic engineering, which is extended front end engineering design. Basic engineering design, it is the final outcome from the front end engineering design, right? Now, the basic engineering schedule, the organization here means the organization are your individual discipline head, your individual discipline who are involved in the basic engineering, right? Any question or any kind of clarification or suggestions? Yeah, everyone is silent. Okay. So here the disciplines are the originator, process. Then next one comes the mechanical, who is ready to catch the ball. Then civil and architecture. Civil, then they are going to develop the based on the equipments and equipment weight and all equipment loads and all. They are going to start the civil data, because unless until civil data is available at the beginning, how you are going to start this project construction at site construction, civil construction cannot wait till you come out with the end of the detail engineering, right? In that way, normally the weight of the equipment is taken as full load weight of the equipment. I mean the equipment like a column. Then in that column, you know the dead load, empty weight, full weight, and this is then they consider as a full load, full water load or whatever the consideration. If the specific gravity is more than one and all, then they consider the full load equipment. Considering that equipment is full, and based on that they considering 20% or 10% of the extra on that weight, they consider the load for the foundation design, and capturing all the zone condition in which zone the site is, so that earthquake and all that can be wind load, earthquake, everything that could be captured in that. So that because the civil excavation, then if piling is required or foundation design is required, certainly that has to be started with since beginning. Okay. Now next comes the electrical. Electrical is one of the discipline who is responsible to process also, and process is going to get deliver the equipment details and all to electrical, so that they should proceed with that. They should proceed with this their deliverable like load list, single line diagram, cable schedule, cable length, everything. Then comes piping. Then piping is also responsible to process. Piping is going to give you the MTO, material takeoff, or BOQ, material takeoff, everything. Material takeoff in first cut, second cut, third cut. It depending on the percentage of the engineering, how much engineering has progressed. There you will get the type of material of construction of the pipe, whether it is a carbon steel, whether it is a stainless steel 304 or SS316, or some exotic material like titanium or FRP pipe. Everything that will depend what code and system, what ASME section 8 division this or whatever the DIN or whatever you are going to follow in that. Based on that they will be going to work out, and that will include SM material also. Then what is the SM material? This is a special material where the steam traps, strainers, like these kind of material that is captured in the SM material. Okay, next one is instrumentation, control and telecommunication. Then all the instrumentation, because instrumentation will proceed with the instrument data sheets. Either they would be using the software like InTools or whatever it is. They will be working on. Simultaneously in electrical, they will be going with that synchronization and that where ETAP and all software that they use the software for. Then control and telecommunication. Telecommunication basically this plant PA system, personal announcement system and all, or now CCTV and personal announcement system, everything. I mean, this all that is part of the your progress of the engineering. Okay. Now next is health, safety, environment. Then this document is prepared at the very beginning along with the process engineering document. Sometimes it's at the time of feed only the first revision that is prepared in that. It is a HSE manual and all. What is for the that particular relevant to that site, relevant to process, relevant to type of equipments. I mean, stationary equipments and rotary equipments, light type of logistics, everything that is captured. Then comes commissioning and operation. Then commissioning and pre-commissioning is also that is captured in the commissioning only. Then after commissioning and test run everything, then comes the operation. This is all related to basic schedule organization. These are the organization who is directly responsible, they are directly related with the basic engineering schedule. Okay. Now the deliverable under these schedules are, I mean, critical deliverables for the process, like this is a design basis. This is the first thing is the design basis. I explained you that day that is the design basis for the process and design basis for the utilities. Everything that needs to be captured there. I'll be sharing with you in the next session how the design basis is prepared, how the design basis, what is the format for the design basis. Because design basis is a very unique document where your client, when you are preparing the design basis and you are sharing with your client or your stakeholders, whoever is there, either your client or for whom you are developing the, they will also appreciate, yes, you whatever the thing you have in mind for the process design basis you have already captured here. Simultaneously, based on that, total steam requirement, water requirement, chilled water requirement, compressed air requirement, raw water requirement, hot water requirement, and any kind of other utilities it is involved, that will be captured in the utility design basis, which will be a separate document. Then comes PNID. I told you that day I asked PNID, piping and instrumentation diagram, not process and instrumentation drawing, not process and instrumentation diagram, nothing. It is a piping and instrumentation diagram. Then cause and effect diagram. Normally, cause and effect diagram that comes out the after the HAZOP. I will tell you in next what why HAZOP. The cause and effect. If you do this, what will be consequences of this cause? What if you do this? What will be consequences of this cause? Because in process plant, you define the whole plant in a different loops. There are various loops. Anybody who is working on a PNID right now? I mean, the current there. I mean, his current assignment is the PNID. Nirmal?
Yes, sir. We are doing ASAP.
Okay, okay. Ashwin?
No, sir.
Okay. Lakshman?
Sir, I am Yogeshwaran. I have worked in PND, sir.
Oh, that's great. That's great. PNID for which kind of plant?
Biogas plant.
Oh, for biogas plant.
Yes, sir.
Okay, so there is a biochemical conditioner reactor BCCR.
Anaerobic digester, sir.
Bioconditional chemical BCCR, biochemical conditioner reactor. Because
Uh,
I did this project for biogas in Jubilant, Gujarat. That time it
mm,
was a VAM organic. There are a lot of molasses waste is coming out, and they used to generate the biogas of very high enriched methane percentage is there in that. So that's good. Oh, that's good. Okay. And with whom? I mean technology from Bioteam, Pune.
no, sir, from iFruits.
Acha, that you were giving. Oh, that's great. That's great. That's great. Okay, that's great. Okay. So like cause and effect. Then comes data sheet. That's the process data sheet. Here the process data sheets are that is developed. Then general arrangement drawing. General arrangement drawing. It means the here that will come. I mean. In all every kind of the originator, I mean section layouts and all everything that will come in the general arrangement drawing, and it is one of the very critical drawing GAD, where in every kind of electrical cable layout, instrument cable layout, or your piping, everyone will need this drawing as a original, I mean origin of that, I mean initiation with that document only. Then comes 3D model. I'll tell you what how it comes. I mean in 3D model what are the various you do the 3D modeling also there.
No, sir.
Okay, okay. Oh, there are, I mean, there are various stages, 30%, 60%, and 90% modeling. Because, nowadays the thing has changing now. Nobody wants like as built drawing and all this thing. Now the latest, now the thing as builds and all that concept is almost overruled now, because as built and all, because there was ultimately there was while doing the piping erection and all, might be there was a clashing classes of the pipelines. In drawing it is there that the pipe is going above this pipe, and there is a gap in between that of gap of like a 10-inch or a 12-inch gap in that pipeline. But while doing the erection at site, you find no, that pipe is clashing to each other. Then then again you need to revise the piping isometric drawing, and then back to back you have to do the piping GAD also, that you need to revise piping general arrangement drawing, you have to revise, and all everything back to back, you have to do a lot of changes in that. So then it comes to modeling. Then while you do the complete modeling, you say no, this pipe is, there is no clash. Oh, here it is a clash. Oh, then take the another route. Then rerouting of the pipe. Then modeling gives you this kind of signals. Okay. Then plan and procedures. Plan includes a quality assurance plan, safety plans, and procedure is a project procedure. Everything that should be there with that. And project procedure manual is also prepared with the help of all these process deliverables, not directly, but indirectly. The project procedure manuals it that defines. Probably any of you, I don't know, have you worked or have you prepared the project procedure manual in detail or not, but it captures each and everything. Project procedure manual, and how will be the project progress will be reported, and what whether there will be the S curve in that, and how the sleekness of the S curve in progress, how that will denote everything that is captured in it. Okay, then comes of the reports. I told you that the weekly progress report and monthly progress report. Then similarly in the safety also, there are a various kind of safety reports are generated. In safety, there are several kind of reports. When if there is a minor accident, then there is a different report format. If there is a major accident, there is a different report format. I mean, there are several kind of formats in that report. And all those things, when you prepare, when you discuss with the client, and so then client, they feel that no, they are something, they are not within the crowd. I mean, crowd, if you see like a batch of school boys coming out from the school at the time of their ending the school, they are coming out together from the gate, like bell is the moment bell is rang, that the crowd is coming out, then you point out, no, though that child, because everyone is wearing the same kind of white shirt and blue pant and but there is a one boy who is wearing not white shirt or something, who is wearing something brown shirt and so you point out, no, 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 that brown boy, the shirt, that boy who is wearing brown shirt, probably he is wearing brown shirt that day because might be he's with he's that day he's having his birthday or something. That is that's why he is wearing some different dress, and that is in most of the school they allow that. Okay, but not everywhere. But so that's why you point out, no, brown shirt. So that is the same thing here also in engineering also. The client said, no, we want this kind of. They know the procedure, they know the documentation, how is this? Because the engineering company, they do not manufacture bread, they do not manufacture masala dosa, they do not manufacture refined oil, toothpaste, anything. They only manufacture documents, papers. And paper is your asset. The type of paper which you give, that should be so impressive in that, so the client should feel that yes, I was looking this kind of document. Yes, I was looking, this is the document sample. He can show his team, yes, this is the document. We don't want this anything something, everything is captured in this document which we are looking for. This is my submission is, you should be always in, I mean, keep in mind that whatever the document and engineering you are doing, you should be something different than others. Everywhere you have to prove that you are the best. Your document which you are working, that is one of the best. Anyway, now there comes the equipment layout. Then equipment layout drawing, I mean, floor wise, or not on only on the ground floor, it is a floor wise equipment layout drawing. That is also prepared by the piping. Somewhere it is prepared by a different group is also there, but normally it is taken care by the piping department. Then sizing calculation. Then equipment sizing calculation, it is the basic layout and all that will be developed by the process only in equipment layout. But how much it will be the difference between these two equipments, whether it is following a statutory norms or not, whether it is there are chances for periodical replacement, periodical maintenance in that, and every after 1 month that equipment dish or bottom that will be opened, then you need to maintain a proper area for that, how much area that is required for maintenance. So that everything that will be, you need to develop in first cut of layout, that process will give that direction, no, this is the our requirement, this equipment will need this requirement, that okay, like distillation column, that the column will be opened, then certainly that segments will be kept somewhere in that area also only. So in some area that area that needs to be I mean cleaned, there should not be any other equipment. Then sizing calculation here, like pressure safety valves, relief valves, these all sizing calculation, that is also a kind of process deliverable. Then material requisition. In any kind of equipment purchase, it is not only with the only specification which process data sheet that has been developed. With that process data sheet, that whole MR, material requisition, a bunch of document will be prepared with the process data sheet. And bunch of document means that MR will define your quality assurance plan, your inspection and test plan, what are the standards that will be followed, and GD2 value, GD2 value if it is a rotating equipment, and any kind of all the other kind of details, every each and every kind of details that will be captured in the material requisition, which that complete set of document that will go to the vendor, and now vendor will start working on that. Then equipment will be that vendor will start the ordering of the raw material, then fabrication, then stage wise inspection, vendor will give you information. Then that after that, that comes QAP. What QAP vendor will follow? Quality assurance plan. So whatever the QAP that has been developed by you, then vendor has to follow that vendor quality assurance plan. And before, while doing the inspection, there is also a document which will be prepared by quality, that is inspection and test plan. Whether this area, this nozzle is to be only for a visual inspection, or is a test certificate, or material test MTC is required, or this thing material test certificate is everything. Now, a deliverable generally follows sequence as the preparation and submission. First prepared, then submit. Then submit for why? For the review and comments. If there is any comments, then you capture the comments and then you revise it and then you resubmit it. Resubmission to not within your organization, it is to your stakeholder, either with this some in between that some companies involved, some EPC companies, some PMC is involved, EPCM is involved, some external agencies involved, or some directly to client. Client will review it and then they will give the comment, and then you incorporate the comment and resubmit it. But one thing is, you always keep in mind, there is a very trick here. Client release the comments in bits and pieces. Sometime they will release the comment on on some portion of the your document, and later on when you second time you submit it, then they come out with the comment on the same portion which they did not recall to give the comment at that time. So then you should say that, you should raise the hand. No, sir, this was the comment was you initially you did not give. Now we have proceeded with the further engineering, and now this we have our the consequence of all this consequence of this is we have to revise other documents, and where there the change note is required. Change note means, that is called extra claim, which is a very important in the engineering. Without engineering and variation note and change note project, I cannot tell you this. This is a very important, and this is very essential or very um, valuable nowadays, because within the project cost only, it is nothing. I mean, it's bits and pieces, nothing to gain much more in that. But yes, you can very vigilant on the each and every submission, and in that client comments. And if you see that there are cascading effect of the client comment, there are several documents that will be changed, or many of the document which you have worked on that, it is superseded, it is not no use, because client has rejected and say, okay, no, this is now our requirement is this, you have to come. Then it's everywhere it is there is a consequences, the variation note will be there. And normally, all the engineering companies, you take Jacobs, L&T, Fluor Daniel, Bechtel, Foster-Wheeler, Black and Veatch, everywhere. They are very stringent in that. They are very stringent in, oh, this is the deviation. See, sir, this is the variation note. They will not send us like process lead or electrical lead, civil lead. They will not send it directly to the client. They will simply say to the project manager. This is the thing which I got this division which was beyond the scope, or this is the repetition here, on this is the variation note for 15 hours or 20 hours or whatever it is, which my team is going to spend on that. You approve it. Then project manager is there maybe to discuss with the client and highlight the client. Then client will say, yes, this have been done, we approve it. Once your variation note is approved, that means change note is clear. It means that amount is additional amounts which you are going to get from the client within this head. Okay. This is issued for design. Then issued for HAZOP. Then these are some of the deliverables which is issued for HAZOP. And there are the, after doing the HAZOP, then there are several comments which comes out in the HAZOP. You need to change this line like this. You need to install a flow indicator here. You need to you need to install a temperature sensor here, or some gas detection system here. I mean, there are, and that means that will be captured in your next revision of the PNID, which is after HAZOP. Because HAZOP comments is very important, because HAZOP committee that is developed, and the report of the HAZOP committee, HAZOP chairman, signed by the HAZOP chairman of the committee chairman, that is very crucial for further engineering. If you have not conducted the HAZOP and not captured all the points, or you can say simply in HAZOP, what has been given, yes, they can say, this like earthen, we have done this, we have taken care for this. That is overruled. Then it is overruled. But unless if there are some major comment on the HAZOP, certainly everything that need to be captured. Then the IFI is normally issued for information. This is IFI category. Then last comes its IFC drawing. Whenever the resident construction manager, he will not touch any of the equipment unless until he is having a IFC drawing issued for construction. If he is doing something, he is doing a big offense within the project. Without IFC drawing, he cannot, and he has to move exactly as per the IFC drawing. Because in between there will auditor comes and he asks, okay, show me the drawing. Yes, you show. Okay, what what channel or ISMB, ISMC, or this is that used here. You say this is this. Then auditor asks, show me the revision number of the drawing which you are referring. But then sometime the construction manager or your project engineer or construction site engineer, they show the revision 1. Then auditor says, no, I got the information that there is a revision 2 only, 2 also. IFC 1, I mean C1 instead of C1, now it is C2. Then what is a C2? No, in C2 this ISMB 150, now it is changed to ISMB 100. Then they got a certain, then auditor say, they give a non-conformatory report. Auditor give a non-conformatory report that there's a deviation. Drawing says this, the site following this. Now the area of the responsibilities, where process is responsible for conceptual study. You have lot of thing based on doing a R&D. R&D has come out with the some drawing of ideas that this product, this new molecule is there for either it is a pharma plant or this is any kind of a new molecule. Then you start the conceptual study. In this, you develop a block diagram or something kind of, not block diagram means not with the complete process flow diagram. You come out with a block diagram or bubble cap diagram with the concept exactly what is there. You do the lot of studies you on net. Yes, this is where it will be, how the market is, market segment is there, marketing report that you get it. I mean, everything it is there. I mean, what kind of engineering that will be there. Then comes process evaluation and selection. For every process, there are several players are there in market. They are sitting there to give you the technology. Process evaluation. Then you need to do the evaluation, which like caustic chlorine. I give you example for the caustic chlorine. There are Thyssen also giving the technology for the caustic chlorine. AKCC Japan, Asai Kasai. Thyssen ultimately it was Ude. Earlier it was Ude. Well, then Ude technology was very much popular for the caustic chlorine chloralkali plant. Other was Asai Kasai. Then another was chlorine engineers. I mean, three, four, there are well established market players were there. And it was a very difficult, I mean, not very difficult. I mean, it was your efforts, process engineer efforts to evaluate the process technology. And I am talking about these, the process technology of chloroalkali, that was a membrane type, membrane cells. That was like similarly, like other process, KBR, Kellogg's. They are also giving a lot of technology, Linde, Lurgi, like cryogenic, like liquid oxygen, liquid nitrogen. There are Linde is also there earlier, which was that was earlier was Praxair also. Now the part of captured by this another taken over by a company. Then this was Inox is there. I mean several several companies, those who are ready with the processing technologies. Now the thing is, process engineer is supposed to evaluate, yes, what is the cost benefit ratio for using this technology, using this technology, using this technology. Because every technology supplier say, I am the best. Now, next one is optimization study. While any of the plant, like process engineer is doing this, like shift in charge, the plant manager he's doing the plant operation, or he's doing the processing in any kind of, and he is supposed to do the optimization study, whether the plant is operating at an optimum condition. In optimum condition, then everything is included in that. Your all the chemical reactions, there's the conversions, the maximum conversion like 78, 80, 84% conversion is there. Then your exchangers efficiency also, your distillation column efficiency also, how much efficiency that is giving, exchanger, heat exchanger, individual heat exchanger, how much efficiency. I mean, kind of all kind of optimization study that will be done by process. Then process development, whatever is the process is going on, a process has been given, what kind of development, what kind of enhancement, what kind of technology enhancement or new modifications, debottlenecking, which I told you, any kind of revamping. I tell you revamping because now the concept is has come up for the modular packages. You must have heard modular packages. All right, for installing 3 or 4 heat exchangers in series, like not in series, at a ground level 1, 2, 3, 4. Now the thing is coming like they give a manufacturer only, they give a modular package like 6 exchanger. They give two at one level, 2 exchanger at another level, two exchanger at another level. Now they have a kind of modular package, or your area has been optimized, or your layout has been optimized. Now, because that your exchanger is now with the comes as a modular package, big 6 feet heat exchanger or 10, 12 feet exchanger, 6 feet heat exchanger. I am telling you because there is a one tube length of 6 meter, one tube length of 6 meter. Then heat exchanger size is 6 meter. Then that is integrated with further, or heat exchanger is cut either it is 6 meter, or it will be tube will be cut like 3 meter, or it will be cut to 2 meter. It will be not like 5 meter, or it will be not like 7 meter or this thing. Then there will be a lot of wastage for the material. Okay. Then comes basic engineering of process plants. Of course, we are discussing a lot for the basis engineering, where it comes for the process engineer for to involve deeply involved in the basic engineering part of the process plant. Then basic engineering of offsites and utility. In offsites, like all tankages, raw material tankages and finished product tankages, including intermediate tankages. Like one, I was talking to he told just about the biogas. So what is the raw material for the biogas? The molasses?
We use rice straw, sir.
Rice husk. Yeah, yeah,
Rice rice straw.
yeah. Yeah, I mean, that is the okay. In mostly, if you go with the sugarcane as a raw material, I mean, bagaj or cane as a raw material in that, then molasses will be the raw material for that. Then it will be fermented. It will go to, I mean, distillation column. Then, I mean, before that it will be pre-fermenter, then fermenter, then it will be it will be to distillation column. I mean, I think you will be following the same process, right? In that distillation,
Uh, no, sir, it's a bit different,
directly
sir.
directly from feed to biogas.
No, sir. First, the rice straw is preconditioned with chemicals, sir, like caustic soda and ferric chloride, and then they fed into a anaerobic digester.
Okay, okay, okay. No, then I
From
mean,
there, it is purified.
okay, okay. And what percentage of methane percentage of biogas you get it?
From raw biogas, methane percentage is around 40%. It is purified to around 75%,
And
70 to
H2S
85%.
and H2S.
H2S, after anaerobic digester, it comes around 2000 ppm. It is purified to 3 ppm to 5 ppm.
Then there won't be any much smell around the plant, right? It will be
Yes, sir.
the smell will be very less. Okay, okay, that's great.
Mm.
Then next comes this hazard, hazard and operability, that is study. This is a hazard study, which is very much essential everywhere. Now, any of the package also, like boiler or hydrogen generation or any kind of in your biogas area also, everywhere that should be HAZOP study, that should be there. Proper HAZOP, it has to be there. All the consequences, all the causes, all the effects, this will be the cause while doing like while doing the aeration in that biochemical conditioning reactor, the aeration, this may be effect, this will be the cause, then this will be the effect, this will be the cause, this will be the effect, like has of this kind of based on PNID. The main input for the HAZOP is PNID. They work out all they go through the PNID, then they do all the loop study, everything in that PNID. Then it start HAZOPs. HAZOP is either for 3 days, 4 days, or sometime it goes for 7 days also. It depends from the type of the plant on complexity and other. Achha. Now, next the thing is energy audit. Now, the energy audit is the most important nowadays. Everywhere it is, everywhere. Nowadays, either one of the everyone is talking for carbon free energy, green technology, green hydrogen, carbon-free technology, sustainability. It is very important. So now you have to be acquainted with time to time. Yes, what are the green technology? What is the carbon-free energy? Many new companies are coming up and coming up with our technology for green hydrogen and all. Many new things, and everywhere. I mean, now they are looking for those kind of chemical engineers, those who can study on that, they can work on that, they can do some innovative studies on that, because most of the thing it was not done in the past. Now next one is commissioning. The process is also responsible for the commissioning. Commissioning is not done by the erection contractor. He is not able to operate the PLC or DCS system, distribution control system, a programmable logic control system, or monitoring the plant and all. It's not supposed to be. Only the process engineer or instrumentation engineer, whoever is the responsible for that, but he is only they can do it. Then debottlenecking and revamping. Just now I told that day also I explained you. Debottlenecking is a very good idea for that. If plant is starving for the water and there is the vent losses from the plant is not achieving the full production. There is design production capacity is 120 tons per day. Either it's a batch process or it is a continuous process. Batch process means like pharma, and like amoxicillin, ampicillin, rifampicin, ranitidine, omeprazole, any kind of new APIs, diclofenac, any kind of API is there, active pharmaceutical ingredient is there. But there they go for the debottlenecking because every small batch has a big cost. There 1 kg of a material that costs about 1,000 or sometimes 5,000 or 6,000 rupees. 1 kg of the material. If they are able to increase 2 or 3 kg of the per day, their monthly cost it goes up. Sometimes the batch cost of in lakhs also. Some of the APIs, which is some that medicine probably it is used in this some cancer, tuberculosis, or some kind of ABT. Nowadays, you are aware that there are system for artillery blood test. Artillery blood test, they will take the sample of your blood and now they will tell you how much oxygen has there which is not converted into carbon dioxide, ABT. Now this is the test. If there is something problem with lungs and all, these are some there. There are also medicine in that. Those are very costly medicines in that. Because there is everywhere is now everywhere it is like process technology, then there is medical, then there is medicines also, new generation medicines is coming up. Like 5G, you have entered in 5G, then medicine and all that also gone in the next generation. And the reason is process development, process enhancement. Because raw materials are the same. It is the same periodic table which was given by Mendeleev. Only hardly few elements, few metal, has been added there in several years now. But where to, which one to which one to add it to which one to become a molecule, which one compound will act, and that advancement. Okay, next. Now the basic engineering package. The process engineering division will be responsible for the preparation of BEP and the major deliverables The major deliverables are, which broad deliverables I tell you. Number one is design basis for process and utility. I explained you design basis, capturing the process condition, process equipments and all, utility and all type of in design basis for utility that will capture all type of utility, process and utility flow diagram, then heat and mass balance, whether these are in which equipment there is a exothermic reaction, then what type of insulation will be there. It will be mineral wool will be there, then cladding will be there, this thing, that thing. And there is a kind of endothermic reaction and all. If there is a heat is absorbing in that, then in that there is a kind of what kind of insulation will be there, and what kind of total enthalpy or what enthalpy or total heat balance and everything, total steam requirement and total water requirement and everything that will comes out. This is the same where a lot of exercises that you do it equipment by equipment. Then same is like mass balance. Every equipment, what are the incoming, what are the outgoing, everything, what is there, what are the losses with each and equipment. If you do the heat and mass balance equipment wise, you can come out with a complete sheet of that. Yes, where why you are not performing, why your plant is not performing. Then from plant not performing to you come out within why this, which section of the plant is not performing, which is giving this non-performance of the overall plant. With from that section, then you come out to do the equipment, why that particular equipment or this equipment or equipments not performing. Then you come out within that, oh, within that equipment, what is the non-conform, whether it is a exchanger area is the bottleneck, or that you might be fluid is to be interchanged, cell side fluid has to be given in the tube side, or tube side fluid has to be given in the cell side, or number of passes has to be increased, cell side 2 passes, tube side 4 passes, or tube side 2 passes, or cell side 4 passes. So in that you have to work out. Then you have to do the designing, where you need to change the baffle plate in that. You need to change the tube area, tube size of that. And then these kind of you do the exercises in that. Then equipment process data sheet. The process data sheets for all the equipment, whatever the equipment, either it is a rotary equipment. Rotary equipment is like all the package equipments, like motor, like rotary package, like boiler, chilled water, cooling tower, everything. I mean that is a part of your package item. This is a rotary package, which comes normally under MEG, mechanical engineering group. Another is FEG, fabrication engineering group. In that, in mechanical also there are several divisions in that. Fabrication engineering group, who is exactly responsible for the fabrication of the equipments. They have kind of expertise of what kind of welding will be used, what kind of fabrication, how steel will be rolled, everything. Now the next term, catalyst and chemical requirement. And if there is any kind of catalyst, then comes like catalyst and chemical requirements. Chemical, yeah, chemical and catalyst requirement. If the process is involving the catalyst, like I give you example for something related to your biogas only. I'm giving you. Okay, now let us say from sugarcane to alcohol, and then from alcohol to with oxidation of alcohol to acetaldehyde. Then further oxidation of acetaldehyde to acetic acid. So then from alcohol, from ethyl alcohol to acetaldehyde, there will be a catalyst required, which is a pure silver catalyst. 99.9% purity of silver catalyst. Pure silver will be used as a catalyst in alcohol to acetaldehyde. So that catalyst, the type of catalyst, quantity of catalyst, because quality of catalyst also deteriorate. You must have heard that catalyst does not take part in the reaction. Only it helps to do the reaction. So in that way, catalyst. And similarly, from acetaldehyde to acetic acid, if you do the oxidation, then the catalyst is potassium dichromate and MnO2. Then now next come utility and raw material summary. Then it comes a utility summary. Utility summary sheet. Exactly what, how much quantity of the utility, how much quantity of the steam will be required, and what pressure, and how much the chilled water will be required. I'll share. I mean, in later classes, I'll share you the what kind of summary sheet is prepared. Utility summary sheet. In that, you need to classify all kind of utility which is going to be used while doing the engineering. This will including all type of water, raw water, processed water, cooling water for heat exchangers, and raw water which will be the input for your water treatment plant, and water treatment plant will give the water to your cooling tower, and cooling tower will give the water for all the heat exchangers. In between that, there are you do the several cooling water treatment also in the cooling tower. I will discuss with you separately for that exactly when we talk about the cooling tower and water treatment plant and all. And this is then data to assist the definition of hazardous area. And of course, if you are having, if you are doing any kind of hazardous material operation, if your raw material of finished product is hazardous, of course, like alcohol, acetaldehyde is it's having a very low boiling point, like acetic acid. I mean, these are then a hazardous area classification is prepared. Zone is defined in that, which is called HAC. Now next comes is instrument process data sheet. Process is responsible to develop this also, instrument process data sheet, IPDS. Because this data sheet will be input for generating the instrument data sheet. Not from the process data sheet, the instrument will proceed with that. This is IPDS, instrument process data sheet, that will be prepared by process, which will be the input for instrument data sheet. Then emergency shutdown. If for any plant there you need to develop a emergency shutdown, how the emergency shutdown is suddenly some is happening or something accident or something equipment failure or fire or any kind of burst, equipment got ruptured or any kind of burst is there, explosion is there, what kind of emergency shutdown, how you need to take emergency shutdown. Then line list and SML, SM special material list. Line list, your all the pipelines that will be categorized size, with the material of construction, with type of fluids, everything that will be categorized in that table from this number to this number with the line number, everything that will be categorized. And in that SM list will also be there. SM list will categorize with all your uh, special materials and all, like steam trap, strainer, I already explained you. Even an kind of flexible joints, gaskets, either it is a rubber gasket or it is a steam gasket or metal gasket, whatever it is. Everything that will be captured. Then plant operating manual. Then everything, it is plant operating manual, and this will include also control philosophy also. This will include control philosophy also. Everything, I mean, your plant manual will define how you are going to start up the plant, how you are going to shut down of the plant. Everything that will be captured along with the equipment number, along with the instrumentation tag number, everything. And in this plant operating manual, you must remember that it is known not only the that will be prepared with the BEP, the process licensor or document which is you are getting, you have been developed with the process. That will include some of the data from the vendor also, like boiler operating manual, like chilled water operating manual, like your air compressor operating manual, because every equipment has a different number. And one of the very most important thing, while you do the engineering, your vendor has to inform that no, you need to follow the numbering system which we are following at our end. Vendor will say no, since last 50 years, 40 years, we are equipment supplying the package and we follow our nomenclature in the our PNID, boiler PNID. We give our tag number, we give, then you have to, your process engineer, no. This is our numbering system. If you want that numbering system which we are following, I can share with you. You need to follow this numbering system so that your complete package we can capture in our document, in our manual. Otherwise, there will be whole mismatch. Your boiler package will have a different numbering system. Chill water package supplier will have different numbering system. Hydrogen generation package will have a different numbering system. Your water treatment like a different, that is a small packages and all. But this kind of this thing, they should follow your numbering system, which is owned by process engineer, process team for that particular project. That's why numbering has a very important in that. Okay. Then comes pre-commissioning services. Then pre-commissioning, before the commissioning of the plant, each and every utility or each and every division is commissioned, and they see that the commissioning is proper for each and every segment. Then only comes the plant commissioning. Individual commissioning of all the packages, individual commissioning that has been checked, verified, and all the checklist has been signed, everything. Then only it comes a plant commissioning. Now plant is ready, so that it should not be there that while the plant commissioning stage, oh, you see, oh, there is from the boiler package, since boiler vendor has supplied this at very late. This one line is a low pressure steam line has not been connected there. This is then it gone. Your commissioning whole schedule will be different. In that way, it is now the company, they are more vigilant. If they give the contract to EPC, they give but they put a third catch eye. The companies, they give a specialist. They give a specialist to another company, like one experienced person, to they hand over the PNID, and they say that this is the plant. You get a team from our end, 2, 3, 4 engineers from my team, and you see, ensure that this each and every line as per the PNID, it is already erected in the plant. Then he starts checking this. Though contractor, EPC contractor or electrical contractor or PMC or engineering, they have done it. but there should not be any setback at the time of commissioning. They give this kind of assignment to another company, another not company, another any kind of a specialized person to ensure that yes, then that person starts with that. Yes, okay, done. This line is done. This line is done. This instrumentation is here. This orifice is here. They start putting this green color, red color, blue color, black color. They follow that, whatever the nomenclature legend they have in that. Yes, it is there. It is there. It is there. Then something it is missing out without as per PID, they will highlight it. Oh, this is not there in that at the site. Because at the time of commissioning, that cannot be done. Pipe cannot be opened to put this orifice plate. Line joint cannot be opened to put the orifice plate and to install the connect the orifice the level. This is flow measurement. And sometimes the process deliverables when the basic engineering package is the from the process licensor or technology supplier. Just your one friend told about working for the sulfur recovery unit. Am I right?
Sir.
Any of
Yes,
you?
sir.
I think
Yes,
he
sir.
is working on sulfur. Yeah.
Yeah, I worked in.
Okay. Okay. So might be. I mean, technology is from. I mean, either it is from Kellogg's or from any other companies. Whatever is. I mean. So in that case, whatever the process deliverables from the process licensor or technology supplier, that will be like number one, if there is a catalyst and chemical data. So what will be the output document? This you can get this RFQ, request for quotation, for catalyst and chemical. For process and operating data, then you have to capture all those data in the operating manual. Conceptual layout, if he has only given a conceptual layout, you have to develop the complete piping uses to make a final layout. Putting all those documents, putting the utility, putting the electrical transformer area, everything that you need to develop it. Then hazardous area classification hack. This is the, they give hazardous area classification. It is part of the process licensor, technology supplier. They will give this. Now, based on that, you will develop the whole electrical and piping, make final hazardous area classification drawing. Then comes the basic single line diagram. Yes, I am using the word basic here because at that time, process licensor, they cannot give you the exact single line diagram because they are not aware of the exact equipment loads and all. Right? To electrical for their use. This will be used by the electrical department. Okay. And then comes motor schedule. So this will also, it will be used for by the electrical for developing the electrical delivery. Motor schedule, they will give you all the type of motor, indicative rating of the motor. They don't know exactly what will be the rating that will be given by the vendor. Actual motor rating. Based on that actual motor rating only, the load and total connected load and load list and cable schedule, cable length mostly that will depend on the layout also, but cable sizes and all that will depend on the motor schedule also, motor rating also. What is actual power rating of that equipment? It is like, of course, you have a pump and you can work out the theoretically this will be the power requirement for this pump. This is the capacity, head and flow is this, and based on that, this is the power. So that is indicative. They will give you the motor schedule based on that only. but the actual power rating, the pump will work on 60%, 65%, 80% efficiency, and based on that, what will the actual power rating motor you vendor is going to supply. Based on that motor rating only, then only electrical will proceed with the actual kind of engineering. Then a specification of raw material, material safety data sheet. I missed out. Properties of all kind of raw materials, finished product and intermediates. Then specification of raw material, exactly what are the complete specification of the raw material, material safety data sheet, because while transporting, no transportation company will take unless until they have the complete material safety data sheet for the raw material of finished product. Then material safety data sheet and other safety parameters, other safety aspect, which is very much critical while operating the finished product or raw material, if it is kind of hazardous nature or any kind of chemical and all. Nowadays, it is a very much mandatory. Either you are bringing it by sea, or you are importing it by some sea, or by road, or anywhere. By sea, now the import of the chemical is a very stringent norms. If that container, that ISO container where the liquid, where the chemicals is stored and imported or transported, so that if it is leaked or something, so what will be the whether it is how much toxic chemical it is, and which country. So that ship is coming from which country, and which country may affect it in that. Everywhere. I mean, now the things are it is entirely 10 means, I mean, environmental aspects and all that is everything. I mean, all that documents, everything that needs to be aligned properly. Okay. Then residual engineering. Then comes the residual engineering. Mostly this residual engineering, which is not given by the engineering company, which you need to do it at your end. And this is a kind of, along with the residual engineering, you have to do a concurrent engineering also. Concurrent engineering, it means you are doing engineering for that, and side by side you have to do the other engineering also, concurrent engineering, which is more relevant for site, which is required for site, which I told you that, like equipment weight of the equipment, that's a equipment specification, and equipment basic data has been given by the process licensor. But actual equipment weight for civil construction, how much will be that weight? Unless until you cannot work out, you cannot proceed with the civil and construction drawing. Of course, you take a assumption basis of that. Yes, on each floor, this will be the total load. Assuming that on each per area per meter, this will be the total load. And floor wise, this will be the total load. And based on that total load, then total what will be the structural design? They start with that. Then comes the flare network design. It is for basically where the flare system is there. How you are networking the flare system. Then updating of all basic documents like design basis, PFD, PDS, IPDS, PIDs. I explained you, I think everything now you are very much familiar. For the moment, if you will just tell me 5 or 10 crucial deliverable, critical deliverable, you can quickly you can say that these are the critical deliverables. It is on your hand, on your tips. Okay, line list and SM list preparation. Line list and SM list. I already explained that SM list, which what this include, or this type of, these are type of special materials. Then thermal design of exchangers. Then again it depends what type of exchanger it is. Either it is a plate and frame type exchanger, plate heat exchanger, or it is a shell and tube type heat exchanger, or it is a spiral heat exchanger, or it's a double pipe heat exchanger. I mean, what type of heat exchanger it is. Then thermal design. You need to do the thermal design. Nowadays, there are many things. I mean, many software as like STRI. There's a heat transfer research. They are, I mean, that is very much popular in that. STRI is widely accepted, widely implemented there. Okay. Now the pump and line hydraulic calculations. But while I suggest you do the hydraulic calculation, line sizes, velocity is equal to flow upon area. You assume that any liquid which is either coming with the gravity flow at the pump suction, it is 3 to 4 feet per second, and if it is a pump discharge, then it is a 5 to 6 feet per second. You take a assumption and this velocity, and velocity is equal to flow upon area, and you work out the area, and then you from that area you work out that the diameter. This now there are a lot of Excel calculations and all, it is there on the net. It is all. But I always suggest you to use your calculation either on the calculator or on the your desktop or laptop, whatever. You do the calculation, you work out that yes, this is the total equivalent length using these all piping fittings, elbows, bends. These are the pressure drop for this is for instrument. This is the for orifice plate, like 0.25 kg per centimeter of square is the gauge, is the pressure drop along. I mean, you need to work out. You need to see. You must have studied about most of them. You have studied Ludwig or Richardson Colson or somewhere. I mean, McVeigh Smith everywhere. In McVeigh, certainly you are not getting all these things in formula. Ludwig is the most relevant book. How many you have studied? How many you have referred? Ludwig? Nothing? Ludwig? No one has referred Ludwig? Anyway, go ahead. Now the documentation preparation flow. This is the type of documentation preparation flow. This is the client information, raw material, production. These are the capacity of the utility and all. Then you work out with the process flow diagram, heat and mass balance, and then this goes to these for these inputs for the PID, PDS, equipment list, utility, and raw material summary. Then from this goes to hazardous area classification. Then material of construction for the pipes. Then instrument process data sheets, line list, special material list, and all this will go to captured in the operating manual. I mean, basically, broadly, this is the flow of the document. This will be something. I mean, somewhere some more documents, like a number of PIDs are more, some PDS are more, some equipment sheets in PDS again it will be break into type of data sheets like stationary, rotary, and what are several types. But in that, some of the material, some of the like hoist, lift, conveyor, that will not come in the PD. I'll explain you later, because that will be taken care by your mechanical division. Only the specifications you need to transfer to them. But you don't need to develop the process data sheet for the lift and hoist and all. I'll come out. I will tell you in that. Now, client for each deliverables. Who are the client for the each deliverables? Raw material specification, production, and utilities. Process, that information will be used to develop the process flow diagram, heat and mass balance. And that heat and mass balance, this will be the input for PID, piping, mechanical engineering group, fabrication engineering group, electrical, instrumentation. And next, this PDS, process data sheet, that will be used for mechanical engineering group, fabrication engineering group, and the piping group. Equipment list, that will be used by all the departments because everyone is a stakeholder for the equipment list. Utility summary, process for outside, OSBL is outside battery limit. Basic engineering package design. Then piping process condition summary, and this will be the input for the piping process condition summary and material of construction for piping. FEG, fabrication engineering. Simultaneously, this hazardous area classification. This will be required for piping and electrical. Now the PID, certainly it will be used for piping. What they will do, they will proceed with the piping routing, general arrangement, isometrics, equipment layout. Then this goes to mechanical engineering group. Then what mechanical engineering group will do with this? To understand the schematic which their package has to handle. They will develop this schematic with that. Then fabrication engineering group to understand the scheme which their package has to handle. Then electrical to understand the scheme which their package have to handle. Though electrical does not have very much requirement for the PID, but yes, sometime they have to refer the PID, and there is a process for the squad checking where all the discipline leads will mark on the PNID, master PNID, using a different color highlighter. Yes, this is done. This is the remark from piping, red color. Green color, this is the from mechanical. This is the black color, this is from electrical. This is the blue color, this is from instrumentation. The master PID. The one set of master PID that will be only as a master PID, which will be a record for whatever the development and how your engineering has developed, that will be captured in that master PID. Next one is instrumentation also. So I mean, they are the stakeholders, these departments, piping, mechanical engineering group, fabrication engineering group, electrical. I mean, they are the client of the process. They will be asking when you are giving the updated PID, you say yes, PID is in, we are developing the PID. We are preparing the PFD. We are doing the heat and mass balance. Yes. Unless until you do the heat and mass balance, how you will come out with the equipment surface temperature, for which mechanical is required. Mechanical has to do with that. What kind of insulation he has to design. Mineral wool will be there, or what kind of insulation, or what kind of aluminum cladding will be there, what kind of he has to develop. And client for each deliverable will be down. Next one is heat and mass balance. That will go to mechanical engineering group for start their request for quotation. That will go to fabrication engineering group to start with the RFQ, request for quotation, and detail engineering. Also, that will go to piping for their equipment layout and plot plan. Simultaneously, the for PNID, PFD heat and mass balance will go for instrument process data sheet. For instrumentation, will start their RFQ and instruments, PSV, control valves, DCS. Then for the line list, this will go to piping. To start with the piping layout, stress analysis. If there are all the now everywhere it is now Caesar, mostly Caesar is used for software for the stress analysis. Stress analysis, reconfirmation of the piping specifications. Then this PID, PFD, and heat and mass balance for a special material list. Wherever there is a steam line, certainly there will be steam trap also. Special, which will be part of a SM list, special material list. Where there is a pump, then there will be a strainer at the suction. Then it will go to piping, and piping will start for the RFQ. Okay. Now, any question from your side? Everyone is silent. Yogeshwaran?
Nothing, sir.
Okay. Now you tell me what is the takeout? What you have? What we discussed so far? Anything which you found most interesting?
Sir, can I know the full form for SM list?
Special material.
What, sir?
Special material.
Special material.
Yeah, like a steam trap.
Okay,
Steam
sir.
trap is not, that will not come in the piping, but it will come in the auxiliaries of piping, which is a special material. Steam trap, strainers, flexible joints.
Okay, sir.
These are, I mean, SM list. You have to develop a SM list separately.
Okay, sir.
Okay, Giridharan?
Yes, sir.
Yeah. What's the takeaway? What do you have got today?
Actually, I
Anything
learned
which is
about, yes,
specific?
sir.
Anything?
Actually, I learned a lot about the basic engineering package, what are the deliverables should be given in basic engineering, the area of responsibility and everything. And the residual engineering, I learned something in that also, like PSC sizing, what needs to be delivered in that residual engineering package and all. I got
Okay.
the knowledge now, sir.
And you are basically from chemical or?
Chemical engineering,
Oh,
sir.
that's great. Then it is a very good, because see, many knowledge, many information you can get it on net. That's how you calculate this and that, how what is the boiler, what is the heat exchanger, anything. But actual in industry, in worldwide engineering company, how document flows. This is not only for which I am telling you. This is a universal in every company. This is the same thing. It is followed. Either you consider very top engineering companies, or you consider Engineers India Limited, or you consider Black and Veatch, or you consider Jacobs, or you can Floyd Daniel, Bechtel. Everywhere the methodology following the path is the same. Okay, Roshan.
So I learned about the basic engineering and the deliverables under the schedule and the sequence of the deliverable through which we have to submit and the process through which the deliverable goes on, and then the area of responsibility, and then the major deliverables in the basic engineering package, then the input documents, and based on the input documents what the how the output will be, and the output documents will come out, and then the finally onto the residual engineering.
That's great.
And the color of the master documents for each discipline, like piping,
Yes.
mechanical, and electrical, and instrumentation.
Yes. Master check print. I mean,
Yes.
PNID. If you are not following in your project, you must start. You must convey it to your team leader or a discipline manager, sir. We should follow this. This will make a practice to our company to go ahead with that. Not only the keeping the PNID on table, let us keep a one big size. Either it is a A1 size PNID. It is, let us keep. It doesn't matter if you have a 20 sheets or 18 sheets or 15 sheets, but let us keep on the set of one set of that particular project on side, and maximum do it red, blue, green, yellow. Then when client comes, you show the PID, see, this is our working. This is, we are at one table. We are at one table and we have an interactive interaction. That's why this is all color has come up here. Okay. Anushi?
Hello, can you hear me, sir?
Anushi is not there?
Can you hear me? Hello.
Yeah.
Yes, sir. It's Anush actually.
Okay.
Yes. What I found interesting in this session of today's session was how the document is prepared and how does it flow from the basis to the end, including from the client what the information is given by to us. Starting from that to the end through the various departments and what are the other flow that I have learned that. So
That's great. Yeah, Vidya? Vidya is not there? Stephen? Stephen? Also not there. Banu?
Yes, sir.
Yeah.
So today I learned about basic engineering and then critical deliverables, which is under deliverable under schedules and deliverables purposes, and then flow sequences, area of responsibilities, and all.
Okay. You are basically from process or other discipline? You are from chemical engineering or
Yes, chemical engineering, sir.
oh, that's great. Then certainly you should follow it very rigorously at many things. You will come up with new challenges, new hurdles. Anything you would like to ask? Any of you would like to ask related to deliverables, related to document flow, anything?
So can you explain about that hack document? What is the class?
Anand? Yeah. Could you speak a bit loudly?
Can you explain about that hack document? What is area classification?
Acha, hazardous area classification.
Yes, yes.
Okay. Now I will discuss it separately. Though now I am briefing you. The hazardous area classification basically this is a non-layout drawing. It is a marked with that. These are the several zones. Zones are defined in that in hazardous area. This area, this zone will be in hazardous area. This classification A, B, C, whatever it is, the classification has been defined, or that area that is the most sensitive area related to where if there is a highly inflammable vapors or some product is handling. I mean, in that area, that how that need to you lay out, you put a different hatches and all you provide in that layout drawing in different type of marking. You identify that this is the hazardous areas. The zone is this is a zone, this is a different zone, this is a different zone. I mean, you classify it. And in process plant, it is a very essential to identify the hazardous area. That's why do the you do the hazardous area classification. Okay. Anything
Okay.
next? Any more question? Paul?
Regarding the RFQ for a catalyst and chemicals, can you
Yeah, yeah.
briefly explain that, sir?
Okay. Whenever you are going to start the engineering, then suddenly if there is an involvement of the catalyst, like I explained you, like potassium dichromate, K2Cr2O7. Okay. Like suddenly, or something, some like sulfuric acid, vanadium pentoxide, V2O5. Unless until you get this complete specification from the your licensor, yes, what type of catalyst will be used, specification, how you are going to develop the request for quotation. Now the request for quotation is required because you need to procure the catalyst, like vanadium pentoxide, like Helder-Topsoe. Helder-Topsoe is the manufacturer of the vanadium pentoxide, or this is what is the name of Cochin based. Earlier it used to be Catalyst India. Uh, I forgot the name of that company who is giving the vanadium pentoxide. So you need to give the complete request for quotation. What kind of vanadium pentoxide? It will be ribs type, or it will be this. It is basically vanadium pentoxide catalyst is like a yellow kind of ribs type, or some different size, shape kind of thing. Catalysts are there. I mean, unless until you get it the complete catalyst detail, you are not able to float the quotation to the market for getting the offer.
Okay, sir. Okay.
Okay. Okay. Now, should we end up here today? Okay. Okay. Thank you, all of you.
Thank you, sir.
And
Thank you, sir.
thank you, Vaishnavi.
Thank you, sir.
Okay. Thank you very
Thank you,
much.
sir.
Okay. Thanks. Thanks.